Hi, my name is Adam, and welcome to today's webinar on the showdown between a Selenium page object and an object repository. In today's webinar, we'll be looking at page objects, the most common way to organize Selenium testing. We'll then be comparing how you could use a page object with a more advanced tool called an object repository. We'll discuss how you can choose different languages and environments for a test framework using the object repository. And then lastly, we'll show you how you can bring it all together using a tool called Rapise that contains a page object pattern, which is a base of a object repository, a framework, and the language all put together. After that, we'll put together a summary and have a Q&A.
So, my name is Alexei, and I'm going to start from a page object presentation. It's a common software design pattern. It's mostly used together with WebDriver to implement web testing frameworks. And here I use a common, well-known example that you will find if you Google for something like page object in Java or something. It would be in the high rates in Google output. So this is common example, and it's common reference on how page object should be implemented. So I took it as an example, and we will also use it for our purposes. So we have kind of trivial demo application, which with simple name, address, zip code screen, and it's doing some trivial registration and passing you to the next screen saying thank you. Page object implementation of for tests implemented in Java would look like that. It's a part of implementation. I just removed something to fit into the screen, and we will look at full implementation a bit later. But key elements are now available on the screen. So what we have here is a page object. Is called sign up page. It's a Java class. It has some web elements defined. In this case, it's first name and sign up button. And it has other two operations. One is enter name, and another operation is submit. So this class sign up page represents the page that we are going to test, and these two operations are called transitions in page object pattern. So these transitions may be used to produce a test scenario by calling them. Now, so this is kind of a very trivial but functional test, and we have a sample of it in Eclipse. So this is our sign up page. It's full version, and it's a test that uses this page object. So the idea here is to have transitions. So once we are going to do something in our test scenario, we may use this object sign up page. Press dot, and we have these transitions in auto completion box. So if I'm choosing one of them, so this development tool, in this case it's Eclipse, helps me to fill values. Which I'm not going to do actually. It's just, so the idea of transition is that. So the test developer may use that. Now, let's look at the page object itself. We see these find at attributes. Those are used to locate actual objects on the screen. So in this case, our test page contains IDs for each element, so locators are trivial. So the idea behind object repository is to separate the logic, which is available here in the transition implementation, and object recognition information, which is available here. So the way how object is located should be separated from the way how we interact with that object. And so in trivial case, object repository would look like that. So it's kind of a resource file containing some identifiers for each of the objects that are used in the application under test. And in many cases, if you Google for comparison between object repository pattern versus page object pattern, what you will find is kind of this implementation saying that this is all that object repository gives you. So this is something trivial, and all the rocking power is actually sits inside page object. Well, I would add here that it's only a piece of the truth because it hides most part of the object repository implementation. So what I would do if I had to use this development environment and enrich this test framework with with object repository, I would enrich the object description. So it may contain not only ID but additional attributes helping to locate specific object. So once we have more attributes, we have more resilient test, because when we try to locate something, we may try different options to find something on the screen. In this case, if something is modified within the application, we have more options on how to recover in the runtime by just trying different location options, and this gives us more flexibility. In addition to that, having those resources saved separately, this opens us a door to automatic recording and learning. So objects may be recognized automatically during so-called recording stage and then used during the test production. This is extremely powerful part of the object repository. And this actually saves a lot of time if it's implemented properly. Last but not least is the thing that really brings the power to the object repository. The last attribute here is object type. So if we recognize object types, if we recognize high-level objects, then object repository shows its true power. What I mean? This is text input field, and for example, this if we work with WebDriver, entering text every time means two interactions, like clearing it and sending keys. So with object repository, if we have text input field, then it would have an operation input text, and it would replace these two operations. So this is a trivial example. In more sophisticated case, the operations may be much more high level, like filling the grid, saving grid data, working with trees. And these operations are not implemented, but taken from the library. So object repository is extremely powerful when it is used together with the object library. So, for example, here is the similar test for different application, but implemented with object repository pattern right here in Eclipse. So you may see we have kind of repository here. Then repository contains information about each element, each web element, just one by one, all elements. And then for each element we have an operation. So for text, and since we have object type defined, each element has its own set of operations. So if I do repository, then get some element like first name, set dot, and here we have operations. We in Inflectra prefer to have prefixes like do. This makes it clear where we have a transition or operation like do clear or do click. and where we have some other type of interaction. So, for example, for text element, we may have just doSetText, and it would actually implement the same two operations that we have here. So this is a trivial example. Now, our application may be much more sophisticated, and we may have operations, we may have objects like grids. So we have many web tests recorded for Microsoft Dynamics for our tool Rapise, and we have deep background in that. So, and usually when you deal with such kind of application, you most probably have a grid, input form, grid, and kind of menu. So, and grid is something standardized. So if you have object type and library support for such a grid element, then with your repository object, you have kind of grid. And here you have grid-specific operations like click on the cell, click by text, save load from Excel, and so on. So, if we had good object library implemented here, then our tests would be much more powerful, even here in Eclipse, with support of recording and playback. But unfortunately, this is something that is still have to become true here. Now let's look at drawbacks, at essential drawbacks that come from the language choice. So we have this environment. In this case, it's Eclipse. It's not something essential. So you may have your preferred environment, and you may have your preferred language. But most common combination is kind of Eclipse with Selenium and with page objects. And so we have Java, we have similar pattern implemented. So we use it as an example. Okay. So let's see what the language brings us. So Eclipse is general purpose development environment. So it has many features intended for application development and debugging, and it has a language. Java is a language which is object oriented. So whatever we implement here, we have to follow object-oriented patterns. These patterns are good for software development of some server-side application development for a complex application, but we implement tests, and idea of the test is that it should be something very short, concise, and clear. Now, let me show you what actually causes problems when we have such a general-purpose language and general-purpose environment used for test development. So, this is our test, and this rows part marked in the upper side is actually part of the test which has nothing to do with test logic. But it is something that we have to write anyway. So we call it here Java formalities. So you have to implement all this. You have to have these keywords. If you're a Java guy with good background, with experience, that's fine. So it's not a problem for you. But if you have a situation which is very common when you have new testers, or you have people who try to migrate from manual testing to automated testing, they have to adopt to that. So they have to go through that stage. They have to get familiar with this programming environment and with this language. Okay, now I marked in the green color. I'm marking the parts related to object-oriented nature of the language. Again, this has nothing to do with actual test we are implementing. It is all about the language we choose. So language tries to be universal. Your test is some universal program, and the formalities you have to follow to make your universal program is actual test. are marked here. Now some more formalities are related to the page object pattern itself. So if you implement object pattern, you have to write these pieces of code for it to work properly. And finally, syntax sugar. Braces, semicolons, @ everything. Again, this is something that not a problem for a programmer, but if you have no programming environment, if you application expert, and if you have some kind of other background but no programmer, that may be an issue if you're not if you have no like engineering skills. So you may see that there is a colored part and there is a white background. So colored part load that we have to accept just to implement what we need, white part, within given environment. It's just additional ballast that we have to carry. Now, so when choosing test implementation, it is worth to think several times about environment and about a language. So if you if you plan to have more testers, you should have proper environment, and they should work in comfortable medium. Well, this is the part where we are going to introduce Rapise. So in Rapise we have page object. In Rapise we have everything that is required for test development, and we have minimal overload or minimal additional things that are not related to test development. So it's a focused environment. And people who are familiar with page object approach feel that it is missing something. But what we're trying to explain here, that we have all those features that you have there, but we removed all redundant things, all things that are not related to testing, to make it the most effective and convenient environment to catch actual goals. So, for example, in this case, we may say that even if Rapise has object repository pattern here, this pattern is actually including page object pattern. All the important features of the page object are already included into Rapise, in addition to all other features related to test execution, like reporting, screenshots, automated execution, and so on and so forth. But it's distributed in a bit different way. In addition to that, we may now switch to kind of live demonstration. So I'm running Rapise. Let me open application that we mentioned in this test. Here is application. So, creating just new test. I'm starting from scratch. Call it like that. Use a web object, Firefox as a browser, and use Rapise Visual Language. Well, we have new test. Now we need to implement it. Simplest way is to just record it. So first Firefox. We have John Smith. And zip code, not too much. And finally, sign up. Well, we have a test. here are the test steps. Here is our page, sign up, and here are objects related to that. These are transitions or operations available for this object. So if I already have these objects, in addition to recording, I may also use like drag and drop to make operation. I don't need this operation actually, it was just demonstration, draw. So I may easily play it back. So let me just close Firefox. So it would open Firefox, fill the form and click the sign up. Now let's see what we have. This is a page, this is an object. This are its recognition parameters. Its recognition parameters are optimized by Rapise, so it has very clever optimization logic to produce minimal XPath. In addition to that, it has more recognition options like name, matching, which is also controllable from here. We just saw report, which I closed, and we have the test, which is concise. We may have most scenarios here, like so. Here are high-level transition. I may use additional logic here. The data here is separated from the logic. So, and if my street name is something containing forbidden characters like backslash, or it's used somewhere like in command like backslash. In case of general purpose language, I cannot just put backslash here. Also, I cannot skip these commas. This is all syntax sugar. I have to know these escape characters, so this affects readability, and it's not a problem for programmer, and as I said before, it's usually a problem for new guys, for newbies. So, well, so here we have page, here we have its objects, and here we have transitions. Benefit of that is with proper tool, like with Rapise. In addition to that, you have all the magic around this pattern. Recording, relearning, reporting, cross-browser, so I may switch a browser in just one click. So it will now play the same with Chrome web browser. So Chrome just opened and it is going to play the same. Reporting and scheduled execution, many other things that you don't have here out of the box and you have here. So our opinion on comparison between page object versus object repository is with right tool, with right language, you actually already have what's called a page object. It's just a part of the environment. So the clean page object, as it is introduced in the tutorials, usually it is mostly explains the way how to apply required things into available development environment and available language. So like 90% of implementation is due to language restrictions or requirements, and 10% are actual page object. And if you go with Rapise, you don't have to follow those formalities. You don't have to deal with those. and you already have those essential 10% that's actually useful within page object pattern. So this is my kind of short answer of the comparison. So if you may consider Rapise as something already have page object on board, but saying that it has just page object is a huge limitation, because it also have object repository bringing a lot of other useful features. So if we try to summarize this comparison, so if we have to implement page object, it's a right column here. So you have to implement pages yourself. You have to have an engineer available who is able to implement those low-level interaction. The tester may use those interaction, and test architect should make it a framework. With trivial object repository, the white part is something that object repository brings to you. And this is it's a left column. It is something really small. It's not a big achievement. It may be some little economy of time. And with good object repository, this white rectangle is much bigger, because much of work that you have to do with other approaches is already done for you. Moreover, this rows rectangle, like tester plus recording, is something that may require an employee with less skills. And of course, you still have to have a test architect who will properly organize it all in test framework, and it's needed in all three approaches. Otherwise, the difference is what you see here on the screen. So this is all I was trying to explain today, and thank you for attention. And now your questions are welcome.
Thanks for watching today's webinar. I hope it was useful. If you'd like more information on software testing, please subscribe to our YouTube channel.